Hello good people and welcome back. In this video we're going to continue with Unit 9, our discussions on swap. And what we're going to start with here is the idea of comparative advantage. And the comparative advantage essentially suggests that a company would prefer a fixed rate versus a floating rate depending on which one of the two market it is that company has a comparative advantage. And to look at it, we want to work with an example, and this is the example we're going to consider. We consider a company, AAA corporation, that really is interested in borrowing at a floating rate. And we are also considering a company which is BBB corporation that wants to borrow at a fixed rate this time. Now AAA and BBB are two different companies with two different credit ratings, right? And so AAA is going to have a better credit rating than BBB. Now the market for capital for AAA looks as follows. If AAA were to borrow at a fixed rate, the company would be borrowing at 4% fixed, and if they were to borrow at a floating rate, they would be borrowing at the LIBOR minus 1% floating for 6 months. That would be the opportunities that are available to AAA should AAA want to borrow at either the fixed rate or the floating rate. Now, BBB on the other hand could have access to capital at 5.2% fixed or LIBOR plus 0.6% floating. And what we can see here from the get-go is that the credit quality of BBB is lower than the credit quality of AAA, which means that the cost of borrowing for BBB is going to be higher than the cost of borrowing for AAA. So comparatively, AAA, which is the first company here with the better credit quality, is essentially doing much better at cost or borrowing in the fixed rate and on the floating rate markets than BBB corporation. And so the way we look at comparative advantage is to suggest that is there a mechanic that can be put in place by these two corporations in order for both of the organizations to benefit from borrowing either at the fixed rate or at the floating rate, or borrowing in the market that is more of interest to the organization. And what we're going to look at is we're going to look at the spread between these two organizations, and we're going to focus on the market that has the shortest or the smallest spread. So we're going to look at the spread between within the fixed rate market. And so in our fixed rate market, this is what we're going to have. We're going to look at the difference between the rate of BBB and the rate of AAA. And that difference here, if we just do the subtraction there, is going to be minus 1.2%. All is to 1.2%, right? The difference is 5.2 and 4. That is a 1.2% difference in the fixed rate market. In the floating rate market, we're going to have a difference of LIBOR and LIBOR cancel each other. So we're going to have 0.7 minus 0.01, right? 0.6, I'm sorry, minus 0.1, and what we're going to have is 0.7. That is that difference that we have here. So it's going to be 0.7. And so what we learn from here is that there is a difference in the two markets that can be taken advantage of. And the way I like to think about this is this idea of arbitrage. So intuitively, what you have is the spread between these two organizations, between the rate that AAA is paying and the rate that BBB is paying in the fixed market, should be about the same in the floating market. So this difference between the fixed rate for AAA and BBB that we have at 1.2 should be about the same in the floating rate market, but it is not. The difference between these two is essentially 0.5%. So what that tells us is that there is some form of arbitrage opportunity that could be put in place in order to take advantage of this difference here, which is the 0.5%. And that process is what the swap essentially is all about. And so a swap can essentially be constructed if that spread is different in the fixed rate market and in the floating rate market. So if these two numbers here are different, then a swap can be constructed to take advantage of the difference here to create even more savings for both organizations that amount to this value that we have here. Now, if you were company B, triple B, what would you be doing? Well, company B would say, well, the market in which I am closer to the best rated organization out there is a floating rate market. That is, the market where I pay the least for capital is going to be the floating rate market. And so triple B has a vested interest in borrowing floating rate at the floating rate. However, you remember that they don't want the floating rate, they really want the fixed rate. So how do we structure a swap between these two companies directly without the middleman, as we had in the earlier video, that takes advantage of this? And that's what we have next. And so in this scenario, what we're going to have is the following. We're going to assume that the notional amount is the same, right? Just like what we had in the previous video. So we're going to work on the same notional amount. That's the idea that they both want to borrow the same amount of money. Let's say 100 million as we had earlier. And the way this is structured is as follows. Well, AAA is actually going to borrow at the fixed rate, which is 4%. That's what the market is for AAA and the fixed rate. Now remember, we said comparatively BBB is more has a vested interest in borrowing at the floating rate, because that's the market in which BBB is as close as possible to AAA, which is the best rated company. That's the market where BBB actually saves. And so BBB has a vested interest in borrowing at the variable rate, but they really want the floating, they really want the fixed rate, right? They are borrowing at the variable rate, but they really want the fixed rate. What they're going to do is they're going to enter into an agreement. And that's what our swap is going to be all about. And for this swap, what's going to happen is AAA is going to pay, remember AAA wants the floating rate, AAA is going to pay the LIBOR rate to BBB, and BBB is going to pay the fixed rate of 4.35 to AAA. What is the net outcome? Let's look at the net outcome here. For AAA, what do we have? We have a loan of minus 4%. That's our loan. And then we enter into a swap. Our swap says we're going to be receiving 4.35%, so plus 4.35%. And we're going to be paying LIBOR, so minus LIBOR. So overall, where are we? Overall, what we have is LIBOR that's going to have to be paid. That's going to be minus 0.35%. And so this is what I have essentially. I'm going to clear this up. So I'm going to have minus LIBOR, right, plus 4.35 minus 4%. And so that's going to be minus LIBOR by plus 0.35. And so because this is the net outflow, I'm going to say minus LIBOR plus minus LIBOR minus 0.35. And so when I multiply the minus here, I have minus LIBOR, and I multiply that there, I have plus 0.35. And so that's what I have. Essentially, AAA is going to be paying LIBOR minus 0.35. That's a net outflow of AAA. So here what we're going to have is minus LIBOR minus 0.35%. That's going to be the net outflow for AAA. Now, what was the offering that AAA had in the floating rate market? AAA was offered LIBOR minus 0.1%. And so by entering into the swap agreement, AAA is essentially saving 0.25%. Right? The agreement that AAA essentially could have borrowed at LIBOR minus 0.1%, but they actually say borrowing at LIBOR minus 0.35%, and the difference between the two is going to be LIBOR, and then we're going to have minus 0.1 plus 0.35. That's going to be 0.25%. So AAA is saving 0.25%. How about BBB? Well, BBB is going to be paying LIBOR plus 0.6%, so it's going to be minus LIBOR plus 0.6%. That's what they have to pay. But then they also enter into a swap, and the swap says they're going to be receiving LIBOR and paying 4.35%. So they pay 4.35%. And then they receive LIBOR. So net, what do we have? Well, LIBOR plus LIBOR minus LIBOR, they cancel each other. And then we're going to have minus 4.35%. That's that value here. And then we're going to have minus 0.6%. That's what we're going to have there. And so the sum of these two is going to be minus 4.95%. That's how much BBB is going to have to pay as a fixed rate. Now, what could BBB have been paying in the fixed rate market? If we go back here, BBB was quoted at 5.2 in the fixed rate market, right? They were quoted at 5.2 in the fixed rate market, but by entering into the swap, they're paying 4.95. So if we do the 5.2 minus the 4.95, what do we have? 0.25%. And so here again, BBB saved the 0.25%. So when we do the sum of these savings, we end up with 0.5%. That is essentially that amount that we refer to as a potential quote arbitrage opportunity. The way I like to think about it anyway is that this represents an arbitrage opportunity where we take advantage of the misalignment of both market, right? Both capital market, the fixed rate market and the floating rate market. Now, in this case, what we have is a scenario where they exchange with each other directly, right? So if they exchange with each other, there is no financial intermediary. However, we remember that based on our discussion earlier, the likelihood that AAA engages directly with BBB is fairly slim. So what we want to be able to account for is that middleman, and our middleman earlier was the Citibank. That's what we used earlier. And so what we're going to do is we're going to include that financial intermediary and see what we have. So now this is going to be the financial institution. And AAA is going to enter into this agreement with the financial institution. and triple B is going to enter in a similar agreement with the financial institution. Now you remember, this swap agreement that we have here has nothing to do with the swap agreement that we have here. The job of the financial institution is to establish those connections, right? But when they are put in place by triple A and triple B, these are not related at all. The financial institution creates those connections, those matching. And so what is the outcome based on what we have here when we include or we account for the role of the financial intermediary or the financial institution? Well, for triple A, we're going to have the same scenario, right? Because we enter into the agreement with the financial institution this time. So triple A is going to have to pay 4% because, again, they're borrowing in the fixed rate market. But at the same time, they're going to be receiving 4.3% from the financial institution, and they're going to have to pay LIBOR. So overall, what do we have for triple A? So overall, triple A is going to have the following. I'm going to change that thickness. Triple A is going to have LIBOR that they're going to have to pay minus 0.33%. And so the difference here is going to be minus LIBOR plus, actually let's just say plus here, minus LIBOR minus 0.33%. That is what this organization is going to pay. That's what AAA is going to pay here. Now, what was AAA quoted in the fixed rate in the variable rate market? AAA was quoted. You should remember that it was quoted at LIBOR minus 0.1%. So, what's the difference? We're quoted at LIBOR minus 0.1%, but we end up with the swap paying LIBOR minus 0.33%, and so that difference here is going to be the LIBOR cancel each other, and then minus plus, so it's going to be 0.23%. That's what LIBOR, that's what AAA is saving by entering into a swap agreement with the organization. Now, 0.23% of a $10 million or $100 million transaction, notional amount, that's a huge amount. How about triple B? Well, for triple B, something very similar, right? So triple B is going to have the following. Triple B is going to be paying LIBOR plus 0.6%, so it's going to be minus LIBOR plus 0.6%. And triple B is going to be receiving LIBOR from the financial institution, so it's going to be plus LIBOR. And triple B is also going to be paying 4.37%. That's going to be minus 4.37%. So the net here is going to be the following. The net here is going to be, remember the LIBOR is going to cancel each other here again. And what we're going to have is LIBOR, not LIBOR, we should have, because LIBOR cancel each other, we have minus 4.37 minus 0.06. So essentially what we're going to have is minus 4.97. That's going to be what triple B is paying in the fixed rate market. Now, what's triple B quoted in the fixed rate? Triple B was quoted, I think it was 5.2. So they quoted 5.2, but they get to pay 4.97. And again here, what do we save? Quoted 5.2, pay 4.97, we save 0.23%. So we are saving 0.32% here, we're saving 0.32% here, which means that in total we are saving 0.46%. So we remember that we said we could save, right? If we took advantage of this mismatch, we could essentially save 0.50. So where is that difference going to? That difference is 0.02% or 2 basis points. So where does that difference go to? Well, let's look at the financial institution. The financial institution is going to get LIBOR from AAA. So it's going to get LIBOR from AAA. That's that transaction here. It's going to pay LIBOR to BBB. That's that transaction there. The financial institution is going to get 4.37 from 4.37 from BBB. That's this transaction here, and it's going to pay 4.33 to this financial institution that we have here to AAA. So overall, what do we have? This cancels that one. We have 4.37 minus 4.33. That's going to be 0.04, and that's 0.04 annually. Net the transaction, we're going to have 0.02 semi-annually. Now this makes me go back here and verify my numbers here. So yes, this should be 0.4, not 0.02, because that adds up to that. 0.04 or 0.02 semi-annually, which is exactly what we have here. So the difference between what we had earlier in the earlier scenario here, both organizations were saving 0.25%. In this case, both organizations are only saving 0.23%, but that spread goes over to, the difference goes over to the financial intermediary, which of course charges a fee for setting up this transaction, and therefore the financial intermediary gets a 0.04% or 4 basis point on the transaction, or 0.02 or 2% for the semi-annual period. All right, so this is the idea or the intuition behind comparative advantage. This idea that you want to borrow in a market in which you have the more competitive advantage or comparative advantage, and if you have a preference for fixed rate versus variable rate, then you can get into that engage into a swap market, into the swap market with the financial institution in order to transform your cash flows. Now, we have to remember that this would only work in a scenario where there is a form of mismatch between the fixed rate market and the variable rate market that creates that opportunity where the swap can be put in place. Now, the criticism that the comparative advantage has gotten is essentially this idea that when you're borrowing the fixed rate market, you're borrowing for a long period. Go back to the board here, and we're going to do that over here. All right, so in the fixed rate market, we're essentially borrowing today, and we are locking in a rate that's going to apply for the entire period. That's our fixed rate market there. However, in the variable rate market, remember in the example that we're playing with a second ago, what we had is a scenario where every 6 months we looked at what LIBOR rate is. So the agreement gets renewed for a period of 6 months, at which point the agreement rates are due for the next 6 months, and then we're looking at another agreement for another 6 months, and another agreement for the last 6 months that we are working with. And so there may be a mismatch between these two transactions here. And by mismatch, what I mean essentially is the fact that this triple B rated corporation that we have here, let's go back here, this triple B rated corporation that we have here that's paying LIBOR plus 0.6% here, is the corporation that is essentially having these renewed cash flows from period to period. And the mismatch may occur if after the swap is initiated, for example, the credit quality or the credit rating of the triple B company, that's the B organization, changes or worsen. And so if this triple B rating reduces to, let's say, double B, the company may not be allowed to pay just LIBOR plus 0.6% because the credit quality has changed. So the company may be required to pay LIBOR plus, let's say, 2%, right? And see, if the company pays LIBOR plus 2%, what does that mean for a swap agreement? Well, it simply means that this swap rate here is not going to satisfy the savings of 0.2623 or the 0.23% per parties, right? So these rates, these fixed rate that we have here, are a function of this variable rate that this organization has to pay. And so you can see the relationship between the swap rate or the fixed rate that we have here and LIBOR, in that the lower rated organization here runs the risk of seeing its rate here, which is the LIBOR plus 0.6%, change frequently because LIBOR gets updated frequently. However, this transaction is entered for a long period of time, which is the swap rate for here. And so if we're working for 3 years, the swap rate is going to be entered for a period of 3 years. However, this loan here gets paid every 6 months and gets reassessed every 6 months by the lender to triple B organization. And that's what the mismatch that I was referring to is all about, is the life of the LIBOR agreement versus the life of the loan that we have here. Is that this is for a long period of time, whereas this is for a series of short periods of time. And that is essentially what allows for us to be able to value if a swap agreement or a swap contract. Now, here what we have is, for that criticism, is the idea that the 4% and 5.2%, those are the long-term rates that are locked in by both organizations in the fixed rate market. In this case, that example, we had, say, 5 years, and the LIBOR rate, which is the floating rate, are typically for short-term rates, right? Those are the 6 months rate. And so those series of 6-month rates may vary quite a bit, and in the event that they vary significantly, the fixed rate that is the result, or that fixed swap rate, is not going to allow for a significant saving by either party of the agreement. Now, triple B stand to lose here more than triple A, right? Because triple A is still safe. Now, triple B is the one paying the variable rate, is the one that has to be, for which the rate has to be updated fairly frequently. So triple B runs the risk more than triple A. So the triple B corporation's fixed rate is going to depend on the spread above the LIBOR that it borrows at in the future. So the fixed rate that triple B gets to receive, or gets to pay here to the financial, where's the middle? There we go. That's the middle one there. The fixed rate here that triple B gets to pay to the financial intermediary here is going to depend on this LIBOR rate that it gets to pay over time. And so that defines the relationship between that swap rate, that fixed rate, and the LIBOR rate. So that, again, there's a relationship that exists between the swap market and LIBOR, and that's where that relationship comes from. Alright, so next what we're going to do here is look at the valuation of swap rate, of interest rate swaps. And our valuation of interest rate swap is going to be a function of the analysis that we did earlier. So we're going to go back to our board. I'm going to try to remember what this analysis that we had here was all about. And in this analysis, I believe that was this analysis here, where we try to identify what are the cash flows that are the result from these swap agreements, and our valuation of the swap contract. Remember, the valuation is the present value of the expected future cash flows, So what we're going to do is we're going to forecast these future cash flows that are the outcome of the swap agreement, and then we're going to compute the present value, and that's how you value swaps. So we're going to work with that with an example. And here we present the process first. So the process is going to be to remember that when a swap agreement is entered into place or is constructed, it is constructed such that the interest rate swap itself is worth nothing or close to zero for the financial intermediary, right? So if it's worth nothing or close to zero for the financial intermediary, it can have a positive or negative value over time. And so the approach is going to be to say that at later times, they can be valued as a portfolio of forward rate agreements. And the reason we are looking at them as a portfolio of forward rate agreements is because we are replacing this series of variable rates, right, for a fixed rate. And so our goal is to see, if we go back to our board here, we're replacing this series of variable rate. Let me use this one. This series of variable rate here for a fixed rate. And so our goal is to see what is the outcome that's generated here at each point, and what are these variable rates that are going to apply here, and how it is that we are able to compute the present value of these cash flows that are generated there. And so the procedure is essentially going to be the following. We're going to calculate the LIBOR forward rate, and the LIBOR forward rates, you remember our computation in a couple of units ago, we computed forward rate as R2T2 minus R1T1 divided by T2 minus T1. And so that was our computation for forward rate agreements. Remember, we work with a portfolio forward rate agreement. We are suggesting that at the stop, at each payment or each exchange, we are resetting, we are entering into a new forward rate agreement, or we have a series of forward rate agreements that are put together and form a portfolio. And for each one of these forward rate agreements are essentially going to be the LIBOR rate that we have, that we are essentially going to forecast. We're going to use those LIBOR rates in order to compute the swap cash flows that would occur if those rates hold, and we're going to compute the present value of those cash flows using the OIS rate, which is overnight index swap rate. And you remember in a couple of units ago we said, well, we wanted to look at the FRAs and the overnight index swap rate, and we also wanted to look at the zero curve, because we are going to use the zero curve here in a second in order to utilize all of them in the valuation of swaps. And that's exactly what we're going to do here. Now we're going to use an example to do just that. Our example here says the following. It says that we have a financial institution essentially that's putting in place this swap agreement, and the swap involves paying 3% per year and receiving LIBOR every 6 months on a notional amount of 100 million. So let's go back to the board here and let's see if we can construct that. I'm going to get rid of this. There we go. So this is what our agreement is going to look like. We have two parties, A and B, and we said that our swap involves paying 3% fixed and receiving LIBOR on a notional of 100 million. So we're going to be paying 3% fixed, and we're going to be receiving LIBOR, and our notional is going to be equal to 100 million. All right. Next, we're also told that the swap has 15 months remaining to life, and the exchanges are going to occur in 3 months, 9 months, and 15 months from today. So the swap has 15 months to live, and so we're going to be starting here 1, 2, and 3, and the payments are going to occur in 3 months, 9 months, and 15 months. We are also told here that the LIBOR rate applicable to the exchange that's going to occur in 3 months was established essentially 3 months ago, and it was established at 2.9%. So we're going back 3 months, and that's 0 here, just today. And we're saying that 3 months ago, a LIBOR rate was established. So we had a LIBOR rate that's going to apply to this period that was established was at 2.9%. And that was LIBOR. So LIBOR rate was established then at 2.9%, and that's the LIBOR rate that's going to apply to that period. Now the LIBOR rate that's going to apply to the next 6 months period, which is this period here, is unknown, and the LIBOR rate that's going to apply to this period here is unknown. So we're going to do the following. We're going to place a couple of unknowns here. So the LIBOR that are going to apply to this period is unknown, and the LIBOR rate that's going to apply to that last period here is also unknown. Alright, we are finally told that the forward LIBOR rates for 9 months, 3 to 9 months, and 9 to 15 months period are 3.42% and 3.73%. Now, these are the results that we're going to be looking for, but we don't know where these numbers come from, and these are the numbers that we need to generate here. We're going to skip this because we're going to come back to this to verify our computation. The OIS rate or the zero curve is essentially given for the maturity of 3, 9, and 15 months. So our zero curve is going to be the following. For the maturity of 3 months, so we have OIS, and we have the maturity here. We have maturity of 3 months, 9 months, and 15 months. For the maturity of 3 months, we are told that the OIS rate is 2.8%, and then we have 3.2% and 3.4%. So 2.8, 3.2, and 3.4. So we're going to have 2.8, 3.2, and 3.4%. And those are going to be our OIS rates for the various maturities. Alright, next what we're going to do is the following. Next what we're going to do is essentially try to identify what are the exchanges that are going to occur. Remember, that's our goal. What are the exchange or the cash flows that are going to occur at this period? What are the cash flows that are going to occur at that period? And what is the cash flow that's going to occur at this period? And then we're going to find the present value of these cash flows. Let's call this cash flow 1, call this cash flow 2, and let's call this cash flow 3. What is the present value of these cash flows that are going to occur at those periods of time using our zero curve? So this will be our zero curve. Now, something that we want to remember is that our zero curve is those rates are continuously compounded, right? So that's what we're going to use. And these rates are continuously compounded, whereas the rates that's given to us here is not continuously compounded. So we're gonna, let's go back here actually and verify that. paid every 6 months, so this is going to be every 6-month payment. That's not continuously compounded. The exchange that occurred there, LIBOR rate is given, and LIBOR rate is at 2.9% for the first period, and we have the maturity of 3.4, 3, 9, 15, and the OIS rate are 2.8, 3.2, and 3.4. All right, so that's what we have. All right, so we can go back to our board, and the question that we want to answer is what are these cash flows? The first cash flow that we're going to have here is going to be equal to, remember we are paying 3%, so it's going to be minus 3%, and we are receiving LIBOR, so it's going to be plus LIBOR, and that's going to have, we're going to obtain that a net amount, and that net amount is going to be multiplied by the notional in order to find the cash flow for that period. Now remember, these are semi-annual payments, so really we should be doing this divided by 2, this divided by 2. For the second one, what we're going to have is still a minus 3%, plus LIBOR, and we're going to find the net amount again, and we're going to multiply that by the notional. So by 2 here, divided by 2 because semi-annual, and multiply by notional. I'm just going to call that notional. Right, so that's my notional. And finally, we should call that notional something else. Let's call that notional capital M. There we go. That's my notional. And I'm going to make sure I call that capital M equal to 100 million. It makes it easy to read. Alright, the last one is going to be minus 3% plus LIBOR again, and we're going to have our net, and as usual divided by 2 here. I'm going to use the same pattern, divided by 2 here, divided by 2 here, multiplied by capital M, which is my notional. These are the cash flows that I'm going to try to establish. The question though that I have is, what is LIBOR that I'm going to apply for this first period? Well, the LIBOR rate that I'm going to apply for this first period is fairly obvious. It's given to us. That's that value here, 2.9%. So that first LIBOR rate is given, and I don't have a problem finding it. What I need to know though is what is the second LIBOR rate here, and what is the third LIBOR rate. And to do that, we're going to use 408 formula. And our FRA simply said that the LIBOR that's going to apply to that period of time, that is between 9 and 3, and I'm going to use the following. I'm going to call this LIBOR 1. I'm going to call this LIBOR 2. And I'm going to call this LIBOR 3. So LIBOR 1 is equal to 2.9%, and that's given to us. LIBOR 2 is going to be equal to the following. R2, and R2 would be R9, so I'm going to call it R9 T9 minus R3 T3 divided by, use different color here to make it readable. I'm going to use R9 T9 minus R3 T3 divided by T9 minus T3. What does that give us? R9 is the 0 rate 9, so that's 3.2. T9 is 9 divided by 12, right? Minus R3, which is 2.8%, divided by multiplied by T3, which is 312, and we divide all of that by T9 minus T3, so that's going to be 912 minus 312. And so that's how we find LIBOR 2. But this LIBOR 2 here is continuously compounded, so we need to transform that into semi-annual compounding. And so let's find LIBOR 2 first, and then we're going to transform it. I'm going to pull my financial calculator here, and I'm going to try to compute this value. So on off, I'm going to do the following. I'm going to do 2.8% multiplied by 3 divided by 12 equal 0.07. I'm going to store that. I'm going to store that 2. And I'm going to do 9 divided by 12 equal times 0.032 equal. I'm going to store that 1. And I'm going to do that's going to be 912 minus 312, that's 612, that's 0.5, so 0.5 there. So I'm going to do recall 1 minus recall 2 equal divided by 0.5 equal, that's about 3.4%. So this is going to give approximately 3.4%. But the 3.4% that I'm going to have here is going to be continuously compounded. How do I transform that to semi-annual compounding? To transform that to semi-annual compounding, you remember the expression is the rate of return semi-annual compounding is equal to the number of compounding period multiplied by the exponential of our continuously compounded rate divided by the number of compounding period minus 1. So that's going to be equal to, here we're going to have 2 because it's semi-annual, exponential of 3.4% minus divided by 2 minus 1. And so we're going to have that. We're going to divide this value here by 2 equal. We're going to take the exponential of that. So second function exponential. We're going to do minus 1 equal. And then we're going to multiply that by 2 times 2 equal. So we're going to get about 3.42% or 3.43%. So approximately 3.42% is going to be our LIBOR 2. Remember, LIBOR 1 was at 2.9. LIBOR 2 is at 3.42%. Now, what is LIBOR 3? And remember, LIBOR 3 is this value here. We just found the LIBOR rate that's going to apply to the second period. Now we need to find the LIBOR rate that's going to apply to this third period here. Now that LIBOR rate that's going to apply to this third period, we're still going to use the forward rate agreement expression. So LIBOR 3 is going to be equal to, in this case we are working with LIBOR 3, so we're going to use the 15-month and the 9-month. So it's going to be R15 T15 minus R9 T9 divided by T15 minus T9, and that's going to give us the following. R15 was the OIS rate 15, so that's 3.4. So we're going to have 3.4% multiplied by 15 divided by 12 minus R9 was at 3.2%. So we're going to do 3.2% multiplied by 9 over 12, and we divide it by T15 minus T9. That's going to be 15 divided by 12 minus 9 divided by 12. And so remember, we're still going to have to convert that, and we still have to convert that in semi-annual compounding. So let's pull a finish calculator and do just that again. So before I do that, I want to clear my memory. So I'm going to get in my memory. I'm going to say second function clear work. Second function clear work in my memory. And so I'm going to do 3.4%. I'm going to start with the first one there. Multiply by 15 divided by 12 equal. I'm going to store that 1. I'm going to do 3.2% multiply by 9 divided by 12 equal. I'm going to store that 2. Now 15 minus 9, that's 6 months, divided by 12, that's going to be 0.5. So what I can do is to say recall 1 minus recall 2 equal, divide that by 0.5, that's going to be equal to about 3.7%. So I'm going to have 3.7% here, but this is going to be continuously compounded. So I'm going to convert that using the same expression that I have here. And so LIBOR 3 is going to be equal to 2 times the exponential of my continuously compounded rate, which is 3.7%, divided by 2 minus 1. And what we're going to have is the following. We have 3.7%. We're going to divide that by 2 equal. Take the exponential of that, second function exponential. And then we're going to do minus 1 equal. That's going to give us that. And we're going to multiply our answer by 2. So we have about 3.73%. So it's going to be about 3.73%. That's going to be LIBOR 3. What is our cash flow like? First cash flow is going to be equal to minus 3% divided by 2 plus LIBOR 2. That gives us a rate, that's our net rate, that we multiply by our notional. So our cash flow 1 is going to be equal to minus 3% plus LIBOR 2. And LIBOR 2, you remember early on we were given LIBOR 2 at 2.9%. So we're going to go back at 2.9%. To convert that to semi-annually, we're going to divide that by 2. That's going to give us our net amount, and we're going to multiply that by our notional, which is 100 million. Our second cash flow is going to be equal to the fixed rate minus 3% plus our LIBOR rate 2, which we found to be 3.42%, which was that one. 3.42% divide by 2 multiplied by a notional, which is 100 million. And finally, we have our third cash flow, which is going to be equal to the following. Is going to be equal to minus 3% plus the last LIBOR was 3.73% plus 3.73% divided by 2 multiplied by 100. Again, these are 100 million, right, for our notional. So what do we have for each one of the cash flows? Now, the cash flow 1, what we're going to have is, I'm going to move that calculator here, is going to be the following. 3 minus, I'm going to say 3 minus plus 2.9 equal, divided by 2 equal, that's a percentage, so we're going to do percentage and multiply by 100, so we essentially going to have the same amount as 0.05. So it's going to be an outflow of 0.05. So we're going to say minus 0.05. Now, we said early on that we would get each one of the cash flow, and then we will find the present value to today, because that's today, the present value to today of these cash flows. And so we can find the second cash flow present value, and the third cash flow present value, and the value of our contract is going to be the sum of those present values. And so our second cash flow is going to be equal to, here what we're going to have is, I'm going to try to move that over here, 3 minus plus 3.42 equal divided by 2 equal 0.21. So it's going to be an inflow 0.21, and these are in million. And the last one is going to be equal to 3 minus plus 3.73 equal, we're going to divide that by 2 equal, and that's going to be about 0.365, about plus 0.365. Now these are the cash flow, and we need to find their present value. So their present value would mean that we're going to use the OIS rate to find the present value of those cash flows. And these are our OIS rate. And you remember that the OIS rate are continuously compounded. So what we're going to do is discount those at the OIS rate for the specific period. Now the first cash flow is made in 3 months, the second cash flow in 9 months, and the third cash flow in 15 months. The OIS rate for the 15 month is 2.8%. So it's going to be 2.8% multiplied by T, which is 312. The second cash flow is going to be 3.2% multiplied by T here, which is 912. And the last cash flow is OIS rate is 3.4% multiplied by T here, which is 1512. Now adding up our present value is essentially going to give me my swap value. And so let's do just that. We're going to work with this one after the other one. So we're going to start with the last one, the last cash flow. Actually, let's do that. Let's do 2.8%. That's the first one. Multiplied by 3 divided by 12 equal, that's 0.07. That's a minus in front there. We're going to do second function exponential, and we're going to multiply that by 0.05 minus equal. So that give us the present value of the first cash flow. We're going to store that one. So store 1, store 1. Now we're going to do 3.2% multiplied by 9 divided by 12 equal, put the negative sign in front, second exponential, that gives us that. We multiply by 0.21 equal, that gives us 0.205, and that's the present value of the second cash flow. We're going to store that too. And then we have 3.4% multiplied by 15 divided by 12 equal, put the negative sign in front, second function exponential. We get that, and we multiply our answer by 0.365 equal, and we're going to store that 3. And our swap value is going to be the sum of all of those. Our swap value is essentially going to be equal to recall 1 plus recall 2 plus recall 3 equal. So our swap value is essentially going to be equal to 0.505181, 0.505181 297. Now, these are in million, right? So far what we did was we had this value not in million. And so if we multiply that by 1 million, we're essentially moving the decimal 1, 2, 3, 1, 2, 3. There we go. So our answer is essentially going to be equal to $505,187.297. That would be the swap value here that we have. That's put in place by this financial institution. Now, to recap what we did is we looked at the cash flows that are generated by the swap agreement. And the cash flows that are generated by the swap agreement are essentially the difference between the fixed rate and the LIBOR rate. So we take that net rate there and we multiply that by our notional. And we do that for each one of those periods. The trick though that we had was we were given the LIBOR rate for the most recent cash flow or the upcoming cash flow, but we do not have the LIBOR rate for the subsequent cash flows. And so we had to find this LIBOR rate, and in order to do that we needed to use our expression for the forward rate agreement, because we said that we would be valuing a swap as a portfolio of forward rate agreements. And so our formula for a forward rate is going to be essentially that R2T2 minus R1T1 divided by T2 minus T1. We covered that a couple of units ago. And so this would be how we would approach that. We find our forward rate here. This is our forward LIBOR rate. However, we remember that these are continuously compounded, because as a matter of fact, you cannot use this formula here. You cannot use this if these rates are not continuously compounded. So these are the OIS rate that we use here. This is our zero curve, and that's continuously compounded, which means that this rate that we obtain here is continuously compounded as well. We need to convert that to quarterly compounded or semi-annually compounded in this case, because the LIBOR rate are semi-annual compounding, not continuously compounding. And so what we have here is our conversion utilizes this expression where we have the number of compounding period, we have our continuously compound rate, and the number of compounding period again. And so we do that for each one of the LIBOR that we had to forecast, and that's what we obtained. And then we use the LIBOR rate along with the fixed rate, and we remember that these happen every 6 months, so we divide by 2 to match the period, and we multiply by our notional amount. That gives us our cash flows, and we find the present value of each one of the cash flows using the OIS rate for the corresponding period, and that's what we're using here. And ultimately we add up those cash flows and we obtain our swap value. And that would be that's the process that we utilize there to value our interest rate swap. So first step is going to be to calculate the LIBOR forward rates. Second step is going to be to find the cash flows that occur at those points in time, recognizing that LIBOR rates that we obtain when we our LIBOR forward rates are essentially forecasted rates, so that only applies if those rates hold, and we're going to use the zero curve in order to forecast those LIBOR rates. And once we find the cash flows that occur there, we discount those cash flows using the OIS rate again, and we sum up the cash flows to find the swap value. Alright, so that's going to be our example here. I'm going to stop here because we're at the hour mark, and I'm going to be coming back in the next video to wrap up our discussion of swap, and that's going to be fairly straightforward. I'll see you in the next video for just that.